This is lecture 4.2 on isotopes and ions. Before we get into what an isotope and an ion is, I want to do a quick review of what an atom is and what you find on the inside of that. So this is a review from section 4.1. So item number 1, don't forget to label with the number here and to have your title and also these little subheadings as well. We're just going to be doing a quick review of atoms. So here's going to be an atom review. We're going to take a look at boron to start with. Boron is an element that has a weight of 11, so it's called boron 11. And we're going to try to figure out the protons, neutrons, and electrons. So if we can list them, protons, neutrons, and electrons. Remember, protons are positive, neutrons are zero charge, and electrons are negative. And if you look at the periodic table, I've also left you a periodic table on the class pages, so you can take a look at this. The actual mass of boron is about 10.811, but we're going to round that to 11, and it's atomic number 5. What that means is that there are going to be 5 protons in the atom for boron. And since an atom is neutral, your protons have to equal your electrons. So that's also going to be number 5, because our charge of an atom is neutral, or 0. How do we get the neutrons? Well, if you remember that all the mass comes from the protons and the neutrons together. These two have to add up to 11. So what number do you have to add to the neutrons to make 11? It would be 6. That's why this is called boron 11. What we're going to look at now is called boron 10. Boron 10. And we're looking again at the protons, the neutrons, and the electrons. Well, the number of protons can't change because it's boron. We're going to learn later that it's the protons that determine what element that it is. So we can't change the number of protons for boron. So the number of protons is going to stay the same as 5. The electrons are going to stay the same as 5 because this is neutral. However, if you take a look, what has changed? This again is the mass. The mass has changed, which means this number must be different. What must this number be? Because these two must add to 10. The number of neutrons is 5. So this is going to be an isotope of boron, and that's what we're going to be taking a look at right now, and these are called isotopes. And the definition of isotopes is the protons stays the same. Notice how it's 5 and 5. So the protons stay the same, meaning the number does not change. However, the number of neutrons changes. Protons stay the same. The number of neutrons changes. The reason why, well, it's actually itself is not changing. There are some elements in the universe that are boron 11, and there are some elements in the universe that are boron 10. That's how the universe was created. Let's go over the main concepts of this. And if the number of neutrons changes, just like we did here, if the number of neutrons changes, what again is changing? This is what is changing. What is changing? It's going from 11 to 10. What does this number represent again? This is the mass. It's the mass of the atom. So the mass of the atom is going to change. So again, the protons don't change, the electrons don't change, but we change the number of neutrons. So if we change the number of neutrons, we're changing the number of particles that are inside the nucleus. And it's the things inside the nucleus that give the atom its mass. So here's another thing, that elements are defined by the number of protons. Elements are defined by the number of protons. So if you change the number of protons, we change the element. So if we change the number of protons, like for example, if we had 6 protons, it's no longer boron anymore. We've changed the protons, it's not boron, it actually would become carbon, which is the next element on the periodic table. Take a look at your periodic table, again found on the class pages. If we go from element number 5 to element number 6, it's now carbon. Because remember, the number of protons is also called the atomic number, and that is very specific for each element. So if you change the number of protons, what happens is you're going to change the element. The element changes. You have a different element if you change the number of protons. For example, we might be seeing this in our lab. There is carbon, and there is a carbon-14. And carbon-14 has, let's see, protons, neutrons, and electrons. It has 6 protons. It has 8 neutrons, and it has 6 electrons. Remember, protons and electrons have to be the same. So 6 plus the 8, these again are in the nucleus. This gives it the mass of 14. This is actually radioactive carbon, which means that it sort of breaks down and changes into something else. And what happens is one of the neutrons in radioactive carbon is going to become a proton. So if one neutron in this radioactive carbon becomes a proton, okay, it actually becomes a proton and it produces an electron. Because what's the charge of this? If you have a plus and a negative, one positive and one negative equals 0. So what happens is the neutron breaks down into a proton and an electron. So let's see what happens to our numbers. Let's see if you can follow this along. Oops. We have protons, neutrons, and electrons. So one of my neutrons, I had 8, just broke down. How many do I have now? I have 7. One of those neutrons became a proton. We previously had 6 protons. How many do we have now? We have 7. And the neutron broke down, this neutron broke down to produce a proton and electron, so we have one more extra electron because this is now a neutral atom, and those have to be the same. And this is called nitrogen 14. Add the masses together. 7 plus 7 is 14. We didn't change the mass, but look what happens. We went from element number 6 to element number 7. Element number 7, if you look at your periodic table, is nitrogen. That's what we've just produced right here. This is now nitrogen, and it's nitrogen 14. So the mass didn't change. However, the neutron became a proton and electron, so the number of protons changed. And again, elements are defined by the number of protons. If you change the number of protons, the element is going to change.